In this lesson, we take a look at the Shadowcatcher material, which is a very useful material to integrate your 3D geometries onto HDRI environments or photographic backplates. So you basically apply this material to the floor plane to catch shadows from lighting within the scene. In this scene, I have this car model on a simple plane. This particular car model was taken from Cinema 4D's Canon browser. The first thing we need to have is an HDRI image for our environment and a backplate from that HDRI. So let's open up the Node Material Editor and load this HDRI from hdrihaven.com called Skylit Garage 4K. If you right click on the preview and choose Open Window to see the HDRI image, so we're going to be working with this HDR image as our environment's lighting. We also have a backplate photograph from the same HDRI, which is this image called Skylit Garage IMG. So load that as well. Right click on the preview and choose Open Window. And this is our backplate. So this is where we're gonna be placing our 3D model and trying to make it integrate realistically with the environment and the image. Now first we need to worry about the lighting with our HDRI map. So create a new Corona Light material and assign the HDRI image as the emission texture. Now create a new Cinema 4D sky and assign this light material to that sky. In the Corona Light material, increase the preview size to 4K. If we hide our ground plane geometry momentarily, for now we need to match our HDRI map with our backplate image. So let's take another look at our backplate image. So there you have it. You can see how the cars are placed. Now if we start rotating our sky, which has our HDR image, at around probably something like 80 degrees, we have a very close approximation to the angle that the backplate was shot from. Now we need to set up the backplate and match our camera angle with what we see there. So create a new Corona Light material and connect the backplate texture as the emission texture. To define this image as our backplate, we need to go to the render settings and under the scene environment tab, enable direct visibility override and connect the light material with the backplate image as the emission texture to the direct visibility slot. Now what we have achieved here is that the lighting will come from the Cinema 4D sky, but this backplate image will be visible in the background instead of the sky. In the Node Material Editor, if you locate the backplate map in the Explorer, right-click on the map and go to the Detail tab. You notice the image was taken with a 21mm lens, so when trying to match and integrate the model onto the image, we need to make sure the camera that we are using in our 3D scene has the same focal length or something very close. And the next thing is to make sure we are working with the same aspect ratio as our image. The current image has a resolution of 5472 by 3648, which gives us a 1.5 film aspect ratio. Keep that in mind. If we go to the render settings window in the output tab, I have already entered that 1.5 film aspect ratio and locked the ratio up there and decrease the width and height to a more reasonable size for now. So 800 by 533. Also, if I select my Corona camera, you can see it has a 24mm lens, which is very close to the 21mm that our backplate was taken with. The next step is to match our camera with the backplate. To save some time, I have already done that with this particular camera that we have, but if I get out of this camera and use a perspective view, then run the interactive rendering, we can change the camera angle, zoom in and out, or even use tools like a camera calibrator tag to precisely match our camera angle with the backplate. If you take a look at this particular backplate image, you notice where we want to place our 3D car is on this kind of downward slope. So that's why if I go to the quad view, you notice not only I have matched the camera, but also rotated the car and the ground plane to match that downward slope in the image. Get back to our main camera and probably adjust the exposure and highlight compression a bit. I set the exposure to around 0.8 and highlight compression to something like 1.4. Now we are done with the lighting and setting up the backplate, and it's time to assign our Shadowcatcher material to the ground plane. So in the node material editor, create a new Corona Shadowcatcher material and unhide the ground plane and assign the Shadowcatcher to the ground plane. The next step would be to connect the backplate photo to the backplate input of the Shadowcatcher material. So click on this backplate button and load the backplate image again. And there you have it. The model is integrated with the backplate. Now the ground plane is turned into a shadow catcher, but the shadows are looking a bit brighter when compared to other visible shadows in the scene. And we have this shadow amount in the shadow catcher material. By decreasing it, we get lighter shadows, and if we increase it, we get darker shadows. If you take a look underneath these parked cars in the garage, they cast these very dark shadows. So let's increase the shadow amount to something like 10 to get similar shadows. Also in the render settings, the secondary GI is set to path tracing because the lighting is simple and we don't need to vouch for UHD cache. Now in the Shadowcatcher material, we have some options. Let's take a look at the important ones. If I enable reflection from the basic tab of the Shadowcatcher, in the reflection section, we can make our Shadowcatcher to reflect our 3D model. So if I set the level to 100% and glossiness to 1, now the car reflection is visible in the Shadowcatcher. When I set the glossiness to 0.85 for now, and this feature obviously could be very useful for simulating a wet road or something like this. Now if I start increasing the Fresnel IOR, the reflections become obviously stronger and more visible. Simple stuff. For now, let's disable reflections. We have this alpha mode which determines how the Shadowcatcher appear in the alpha channel. When set to always solid, the Shadowcatcher will be displayed as an opaque geometry with a white color in the alpha channel. If set to always transparent, the Shadowcatcher will be considered transparent and therefore black in the alpha channel. We also have this special for compositing mode. If you wish to do the compositing of the car over the backplate image in a compositing app like Nuke, Fusion, or After Effects, you can set the mode to for compositing, and when using this mode, we obviously need to use the beauty pass. So if you get back to the beauty pass, you need to make the map defined as the direct visibility black by using a black color in the light material that is assigned to the direct visibility override. So let's just set the mixed strength for the map to 0% and set the color to black. And now we are using a simple black color as the direct visibility override. And now you can take this beauty pass and place it over your backplate image in your favorite compositing app, and it should look quite similar to the render that we get when the alpha mode was set to solid. Let's set the alpha mode to always solid and set the mixed strength to 100% again for the backplate light material. And for the final render, let's increase the resolution to 1800s by 1200s. And set 16 passes as the pass limit, and the noise mode can be high quality denoising. Also, if we select the backplate image in the material editor, we can set its sampling or filtering to none to get crisper backplate image in the final render. And now we can start the final render. Let me just stop the render and show you the final image and the final render. So there you have it. Very cool. So that's about Shadowcatcher Mateial and integrating 3D models onto photographic backplates in Corona for Cinema 4D. See you in the next lesson.